Hello, beautiful people, and welcome. This is going to be part one of your practice test. We are calling this Unit 6B. So in your book, it's still part of Unit 6, but this is including modules 15 and 16. So everything about logs, exponents, things like that. Again, disclaimer, if you hear a loud bell, I apologize in advance. We are on campus. If you hear the intercom go off, again, I apologize in advance. Also, I am human, so if I make a mistake, that's okay. Let me know where the mistake begins. And so that way I can change it and make sure that you guys are learning from my mistakes so you don't make your own. And okay, so let's go ahead and get started. Number one, solve each equation. So the first thing I notice is I have exponents, and in my exponents I have variables. So somehow I need to evaluate what that is. I'm also noticing I have an 8, a 32, and a 1/4. Right away, in my head, I'm thinking twos. I know that we have 8, 32, and 4, and I know that on each one, I can rewrite each base in the form of a 2. So how this would look like is I'm going to change each base to the same base. And again, only do this if it's possible. In this case, it is possible. So I have 2 cubed. I know 2 cubed is 8. We still have that negative 3k there. Times 32, I know that is 2 to the 5th power. Oop, I shouldn't have put parentheses like that. That's okay. I still have that exponent of 3k minus 3. Now this one here, that 1/4, I know that 1/4 is 2 to the negative 2 power. So this negative makes the base, takes the reciprocal of the base. So this negative makes this 1/2. And then 1/2 squared is 1/4. So now that you have the base common or common base, let's go ahead and simplify this. So I have 2, let's see if my pen can work. 2, this is 3 times negative 3k. This is negative 9k times 2 to the 5 times 3 is 15, k minus 15, and that's equal to 2 to the negative 2. Again, when we have the same bases, what happens to the exponents? And we add them. So I have negative 9k plus 15k minus 15. That's equal to 2 to the negative 2. Then this one here simplifies to 2. Let me shift the paper a little bit. Negative 9 plus 15k, that is 6k minus 15 is equal to 2 to the negative 2. This is where we get to use our wonderful one-to-one property, meaning if our bases are the same, that means our exponents are equal. So I have 6k minus 15 is equal to negative 2. I'm going to add 15 both sides. So I have 13 is equal to 6k. Therefore, k is equal to 13/6. Okay. Let's move on to question number 2. Rewrite each equation in exponential form. So, okay, we are given something in a log form. We need to convert that into an exponential form. Recall, here's my thinking bubble. When we have log base b of a is equal to x, that means in exponential form, we can rewrite this as base b. What does it mean to be a logarithm? A logarithm is an exponent, and that's equal to a. Sometimes you'll see it drawn out this way. So here's your base, here's your exponent, and here's your of. Okay. So base exponent equals a. You can kind of see it that way as well. All right. All right, let's get started. So how do we write this? Here's your base. So my base is x. Here's your exponent of y. And then you have 356 divided by 199. Now again, read the directions. What does it say? All it's asking us is to rewrite. So we're done. If it's asking us to evaluate, then that's completely different. But since it's asking us to rewrite, just rewrite it and put a box around it and move on. Same thing. Where's your base? Your base is 8. What's your exponent? Your exponent is -2. And that is equal to 1 over 64. Again, what is it asking you? It's just asking you to rewrite. So there it is. All right. Number 4, rewrite each equation in log form. So now we're going from this exponential form to log form. Same thing. What does it mean to be an exponent? What does it mean to be a logarithm? A logarithm is just an exponent. So, okay, log, keep your base. Your base is now m. Here is your of. So like if we do base b of a, so it's now base m of 190. What does it mean to be a logarithm? It is an exponent. So we have equals to -13. Okay, let's do this one again. What is your base? Here's log base x of 65 is equal to y. And I'm kind of hesitating, not hesitating. That's a bad choice of words, but I'm actually looking and I'm thinking there might be a similar pattern. Do you see how we went base exponent equals a? I'm looking at it the same way. Here's your base of a is equal to x. Let's see if that works. So if I go this way, so x of 65 exponent is y. Oh, it does work. Do you see that? Base of 190 is equal to the exponent. Just be careful when you do that. I would probably go back to the definition of what it means to be a logarithm. Just be careful with the arrows. Okay. Evaluate each expression. Evaluate. Oh my goodness. This word, you guys, I don't understand why. You guys gotta tell me why this word gives you so much trouble. Evaluate is another word for solve. Solve. Evaluate means solve. If you're not sure what evaluate means on the test, raise your hand, ask me, what does evaluate mean? But you should know that evaluate means solve. Okay, so we are solving. You do not need a calculator for this. Okay, do not use a calculator. Rewrite this. Here's your base. Here's your exponent. So log base 5 of 125 means 5 to what power is 125? Your answer should be 3. Okay, again, 2 to the x is equal to -164. Okay. 2 to what power gives you a negative number? That is not true. Like this can't happen because of this negative. So our answer is undefined. Now this one is saying use the calculator to approximate each to the nearest thousands. So that's 3, tens, hundreds, thousands place. Okay, this is where you need to use the change of base. So you need to remember that log of a divided by log of b. So we have log of a, which is log of 43 divided by log of 3. We're going to type that into our calculator. So in my calculator, log of 43 divided by log of 3. And it's telling us to round to the thousandths place. So that means 3 decimal places. So here's 3.42. The next number is 3, but the one after that is 5. So round accordingly. This should be 424. Find the inverse of each function. Okay, these ones are fun. I'm actually going to use a separate sheet of paper so I can write this a little bit larger for you guys. And that way you can see this a little bit better. Okay. Don't let the log trip you up. It's just an exponent. Don't worry about it. So steps for inverse is exactly the same thing that we did before. Step number 1, is rewrite in terms of y. So for example, change your f of x or f of whatever to y. After that, you're going to switch your x and y. After that, you're going to solve for new y. And after that, I cannot stress this enough, change new y to inverse notation. Don't forget about this last step. That's it. That's it. Only what, 4 steps? We can do it. I know you can do it. I believe in you. Let's get started. Okay, so we have, I'm going to shift this over. For number 9, we have y is equal to log base 4 of negative 3x. Step number 1, change it to a y. It's already a y, so I don't, step number 1's done for me. Now I only have 3 more steps. Step number 2, switch x and y. So now this becomes an x, and this becomes a y. Step number 3, solve for new y. So again, if you see something with a log, convert it to an exponent. So I have base of 4, exponent is x, and that's equal to a negative 3y. How are these two attached? Again, so what's our goal? Our goal is to solve for new y. Get y alone. So get y by itself. So this negative 3 is attached to y by multiplication. So I'm going to divide by negative 3 both sides. So y is equal to 4x is, 4 to the x power divided by negative 3. Again, are we done? No, we're not done. Okay, we need to rewrite this in terms of inverse function. That way we know that it's the inverse of the original. Okay, now if you want to move this negative out in front, go for it. All right, that's number 9. Let's move on to number 10. I'm going to rewrite number 9 here. So again, really quick, we have switch x and y. Rewrite in terms of an exponent. Solve for y. And use proper notation. Okay, let's do that one again. I guess not that one. Let's do the next question. Let's work on the next one. I'm trying to find a good marker for you guys so you can see. That blue one was very nice. Where's my blue? Can't find blue, so I'm going to use purple. All right, again, switch x and y. Here's the thing though, you guys. This is a bubble. Make sure the bubble is alone before you switch anything to an exponential form. Make sure bubble is alone. So I'm going to subtract 10 both sides first. So I have x minus 10 is equal to log base 5 of y. Again, now rewrite this. So I have base 5, exponent is x minus 10, and that's equal to y. And then I am looking back at our steps. So we switched x and y, we solved for new y. Did we solve for new y? We did. Look, y by itself, get y alone, so it is alone. And so the last final step is just to rewrite this in proper notation. And you're done. Okay, we got 2 more inverses here. So we have, what do we have here? Oh, do you notice how these had started out with logs and then we converted them to exponential form? Now we have exponential form and now we have to convert to log form. Same steps applies, nothing changes. Step number 1, switch your x and y. I guess that's technically step number 2. Step number 1 is to rewrite it with a y if it doesn't have a y. Either way, you're rewriting, switching x and y, solving for new y. So I have x minus 3 is equal to 4 to the y power. Okay, Now here's the tricky part. We need to solve for this y. How do we get that y down below? You're going to actually take a log of both sides, or instead of taking log of both sides, you can go back to using the definition of a logarithm, which means here's your log, here's your base, okay? Here's your a value, and here's your exponent. Now, if you were to take logs of both sides, so if I were to take this step here, again, you can choose to do this if you want, and take log base 4 both sides, I would have log base 4 of x minus 3 is equal to log base 4 of 4 to the y. This right here is a property, okay? This is a property. This whole thing is now equal to the exponent, which is y. Both ways give you exactly the same thing. I tell my kiddos, you are using the property by using the definition. So what does it mean to be a logarithm? Convert that, and then you are using that property. All right, let's go move on to number 12. Number 12, let me go back to that purple. Step number 2. Step number 1, here's your y's. Step number 2, switch your x and y's. Get that y by itself. And then again, I'm going to get rid of that negative. So I'm going to multiply everything by negative 1. So I have negative 3x is equal to 4 to the 5th, 4 to the y power. Then I'm going to take log of both sides, or use the definition. What does it mean to be a logarithm? A logarithm base 4 is an exponent. So exponent is last. That's it. Oh, just kidding. Oh, did you guys have a heart attack? I just had a heart attack. Look at this. Look at that. Shame. Shame on teacher. Let's change that. And I'm going to cheat a little bit because I'm running out of space here. So I'm just going to get rid of this y, get rid of this y, and get rid of this y. Because y doesn't belong there. We need proper notation. Proper notation. Proper notation. It's an inverse function, needs proper notation. All right, expand each logarithm. Use a property. We know that if it's dividing, we are subtracting. And then we have this 5 right here. Now you can do this both, like not both ways, but you can do this 2 ways. So the first thing you can do is use the property to bring that 5 on the inside. So basically what you have here is log base 6 of x to the 5th power and y to the 5th power to the 5th power, which means you have log base 6 of x to the 5th power divided by 5 times 5 is 25, y to the 25th power. Then you can apply the property which says, hey, if we have division, then we can subtract. So we have log base 6 of x to the 5th power minus log base 6 of y to the 25th power. We're not done yet because it's expanding. So then take your exponent, bring it out in front. Take your exponent, bring it out in front. So 5 log base 6 of x minus 25 log base 6 of y. Now, if you do it the other way, if you know which way I'm talking about, do it that way. If you don't know what I'm talking about, you can ask me a question in class, but I would recommend this way, okay? All right, let's move on to number 14. I'm going to switch markers so that way you guys can see the difference between the two. Oh, I found my blue one. Okay, so okay, this is how you do it. These two things are being multiplied. So you have log base 9 of c to the 5th power plus log base 9 of root a. Now convert that root a to have an exponent. Oops, this is c to the 5th power plus log base 9 of, this is a to the 1/2 power. Take your exponents, bring it out in front. Take your exponents, bring it out in front. You have 5 times log base 9 of C plus 1/2 log base 9 of A. All right, let's go ahead and flip the page whenever you're ready. Oh, sorry guys, I was looking at the time, making sure you guys don't hear that very loud bell. All right, now it's asking condense. Now we're putting stuff together. So if we see a plus between two logs with the same bases, we're going to, what are we going to do? We're going to multiply. Multiply. Now if it was subtraction, we would have to divide. Okay, anytime you see a number, you have to put it, ooh, that arrow belongs on the x as an exponent. Anytime you see that number, put it as the exponent. So we have log base 5 of x to the 6th power plus log base 5 of y to the 6th power. Now because, again, we have that addition, we need to multiply these two things together, condense, put them together. So log base 5 of x to the 6th power times y to the 6th power. And now if there's nothing more to put together, then you're done. Again, what is it asking us? It's asking us to condense, to put things together, make it smaller, make it simpler. Once you've done that, you're done. Again, I see a plus here. So I have, ooh, this is a trippy one. You guys see this divided by 3? I'm actually going to rewrite that because to me, I don't like that divided by 3. So 6 times log base 9 of 5 plus, watch this. Anytime you have a divided by something and you have a log out in front, that means you are multiplying by a fraction. So what you have is 1/3 times log base 9 of 12. Now that we have that, you guys can work with this. Again, we're putting stuff together. We're undoing the expansion. So we're taking our numbers out in front, putting them back as exponents. So log base 9 of 5 to the 6th power plus log base 9 of 12 to the 1/3 power. Then we have, again, we're putting stuff together, addition. So now we're actually going to multiply. So I have log base 9 of 5 to the 6th power plus, oh, just kidding, this is multiplication, times 12 to the 1/3 power. This is where my calculator is going to come in handy. Although I can probably figure that out, I choose not to. And my calculator's not working properly, so I'm gonna take a few moments here. I apologize. And this one here, for number 16, the only thing that we have to undo here, you can leave it like that, because in my calculator it's giving me some weird stuff. So I know that log base 9, 5 to the 6th power is 15625. And then this one right here, we know that the 1/3 as an exponent just means cube root. So I'm just going to rewrite it as cube root of 12. And that is the final condensed form. Look at number 17. It's asking us to solve each equation. So again, evaluate or solve. Same thing. So evaluate each equation, solve. Whenever you see that, be careful. Don't let the words mess you up. Okay. Solve each equation, give an exact answer. Do you see how this exponent right here has that variable? So that base and the exponent are glued together like in a bubble, okay? So you cannot unglue them. You cannot undo